Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter air and its constituents. In the earlier session we have seen what are different constituents of air, what is the composition of those constituents, and one of the components we have discussed already about oxygen. So now in this session we are going to discuss about nitrogen and carbon dioxide. These are also components of air only. These are also present in the considerable amount in the atmospheric air. Now let us see about these constituents. Okay, first let us see about nitrogen. Nitrogen was discovered by Daniel Rutherford in 1772. He noticed that when carbon dioxide and oxygen were removed from air, the air that remained was inactive and the animals died in this gas. That's why he called this gas as azote gas. Okay, Daniel Rutherford, he discovered this nitrogen gas. How did he done it? He removed oxygen and carbon dioxide present in the atmospheric air. Then he found the remaining gas or the remaining air is being inactive and it is being non-supporter of combustion, and even animals died in the atmosphere of this gas. Lavoisier named this gas as azote, meaning lifeless. So, in the presence of this gas, as animals are being died, the name azote is given for this nitrogen gas at the starting. So, that means azote means lifeless. Okay. Later, Chaptal in 1823 named this gas as nitrogen. So, later the name nitrogen is given to this gas in 1823 by Chaptal. In this way, nitrogen gas is discovered, even though this gas is being present in the atmosphere in the larger quantity. Till the 18th century, it was not found as it is nitrogen. For the first time, Daniel Rutherford, he discovered this gas as being inactive gas. And even later, Lavoisier also done experiments with this gas, and he found that animals are being died in this presence of this gas. So he called this gas as azote gas. Finally, Chaptal in 1823 named this gas as nitrogen. How this nitrogen is being occurred in the atmosphere? Nitrogen is the largest component of air, constituting around 78% by volume of air. Isn't it? In the atmospheric air, most abundant gas in the atmospheric air is nitrogen. We have heard this. What is the percentage of nitrogen gas in the atmosphere? It is around 78% is available. In the earth crust, it is present as nitrates such as niter, which is chemically potassium nitrate, KNO3. Potassium nitrate is commonly called niter, and sodium nitrate, NaNO3, it is commonly called child saltpeter. So in this form, in the form of nitrates, nitrogen is present in the earth crust. In the free form, it is existing largely in the atmospheric air. Around 78% of atmospheric air is nitrogen itself. Okay, so in this way, nitrogen occurs in both free state as well as in the combined state. So proteins are nitrogenous compounds that are present in all living things. So not only nitrates in the earth crust, in the form of proteins also, this nitrate is available in all the living things, isn't it? This is we say in the biology you might have heard, these amino acids, they form proteins. So these proteins are present in almost all the living things. So these proteins are made up of nitrogenous compounds. The compounds of nitrogen are the basic building blocks of these proteins. So in this way, in the proteins, in all living things, nitrogen is present in the compounds form. Okay, it is there in the living things. It is existing in the earth crust in the form of compounds. Even it is there in the free state in the atmosphere. Okay, in this way, nitrogen is occurring as in different forms. What are the properties of this nitrogen? It is a colorless, tasteless, and odorless gas, isn't it? even though it is present in the atmosphere, we are able to see all the things through that because of its colorlessness. We are not able to feel its smell. So this is colorless gas. So nitrogen is a colorless, tasteless and odorless gas. It is slightly lighter than air and is very slightly soluble in water. This nitrogen gas is slightly lighter than air. So this density is compared with the density of atmospheric air. So atmospheric air is consists of so many gases. Its density on average it is calculated as 14.4. The density of atmospheric air, vapor density is called. So it is 14.4 for atmospheric air. Whereas for the nitrogen, for individual elemental gas, vapor density can be calculated by using its molecular mass. So we are going to learn about these molecular masses in further classes. Now the density or vapor density of nitrogen is taken as 14 because its molecular weight is 28. So molecular mass by 2 gives its vapor density. So here the vapor density of nitrogen is 14, whereas the vapor density of atmospheric air is 14.4. So what we can say now, if we compare these two values, nitrogen is slightly lighter than air, just slightly lighter than air, and it is almost insoluble in water, or we can say slightly soluble in water. It is neither combustible nor a supporter of combustion. Yes, we have studied earlier in the classes like about oxygen. What did you say its combustion nature? Oxygen is a non-combustible gas and a supporter of combustion because the oxygen gas is must for the combustion of any fuels that we have studied. But here nitrogen, it is not a supporter of combustion and even it is non-combustible gas. That means it won't support the combustion of other substances. At the same time, it won't combust itself, it won't burn itself. It won't burn and it won't help the burning of other substances. That is the meaning of this neither combustible nor a supporter of combustion. Okay. It does not easily react with other chemicals. Yes, actually nitrogen is a least reactive gas. It won't participate in the chemical reactions generally. It won't react easily. At certain conditions only this nitrogen will participate in the chemical reactions, but unless it will be least reactive. Okay. Significance of nitrogen in the atmosphere. We are telling this nitrogen gas is present around 82% in the atmosphere. Isn't 78% in the atmosphere? What is the significance of this much of nitrogen presence in the atmosphere? Let us see that here. It dilutes the activity of oxygen. This is a very importance of nitrogen being in the atmospheric air. It dilutes the activity of oxygen. What is the activeness of oxygen? It helps in combustion of fuels. So if there is no nitrogen gas in the atmosphere, fuels will burn very rapidly in the atmosphere. But nitrogen will help to control the burning speed of oxygen, to control the combustion property of oxygen, so that we can say it dilutes the activity of oxygen. Thus the combustion of fuels during burning takes place at a moderate rate. If there is no nitrogen, fuels will burn very rapidly. They may cause explosions too in the presence of oxygen. So along with the oxygen in the atmosphere, this nitrogen gas is also there. So as this nitrogen gas is present in the atmosphere, it slows down the combustion speed. It controls the action of oxygen on the fuels. So it is very important in this way. The compounds of nitrogen are vital importance to plants as they help the parts of manufacture proteins. Isn't it? So in the manufacturing of proteins, this nitrogen is or the nitrogen or the compounds of nitrogen are very important. They help in production of these proteins in the plants. So however, free nitrogen cannot be absorbed by plants. We are telling the compounds of nitrogen are very useful for the plants in the preparation of proteins in the body in the plants. But these plants, they cannot take the atmospheric nitrogen directly. Means free nitrogen they cannot take. That free nitrogen should be converted into usable compounds of nitrogen. That will be done naturally. The free nitrogen is converted into compounds by some natural methods. In the nature, the free atmospheric nitrogen slowly converts into the compounds of nitrogen which can be used in the plants for the preparation of these proteins in them. So that process occurs naturally. Let us see those process how it is occurring in the nature. The conversion of atmospheric free nitrogen into compounds of nitrogen which can be used by plants. So one it is shown here. During lightning, an electric spark passes through air. So when it going to rain, we observe some lightning in the atmosphere, in the sky, isn't it? So during this, certain electric spark pass through the air. So due to this electric spark, nitrogen combines with oxygen to form nitric oxide. Generally, nitrogen and oxygen both are mixed in the atmospheric air. They won't react because nitrogen is least reactive. It won't combine with oxygen generally. But in the presence of high electric current, how it is being produced? From the sparks. So when sparks produced, during lightning, these electric sparks are passed. So because of this electricity produced through these electric sparks, this nitrogen gas combines with the oxygen to form nitric oxide gas. So this is a reaction occurs when the electric sparks occurred in the sky. So nitrogen, atmospheric nitrogen reacts with oxygen, so they form nitric oxide. This nitric oxide further reacts with the oxygen and water vapor present in the air to form nitric acid vapor. So what happens? This formed nitric oxide, it further reacts with oxygen to form nitrogen dioxide gas. This nitrogen dioxide gas dissolves in the water, in the rainwater, otherwise water vapor present in the air. So when this nitrogen dioxide gas dissolves in the water or water vapor or rainwater, it forms nitric acid vapor. So when it rains, what happens? This nitric acid formed in the atmospheric air dissolves into rainwater. So it forms like a acid rain. So when it rains, the nitric acid in very dilute form is washed down to the earth, where it reacts with the soil carbonates to form soil nitrates. So what is happening? First, atmospheric nitrogen reacting with oxygen in the presence of electric sparks converting into nitric oxide. This nitric oxide further reacts with the oxygen, forms nitrogen dioxide. This nitrogen dioxide dissolves into the water vapor present in the air and forms nitric acid fumes or nitric acid vapors. These nitric acid vapors, when it rains, it dissolves into rainwater and it reaches the earth in the form of acid rain. Have you heard acid rain ever? Yes, this is happening in this way. So nitrogen dioxide gas dissolves into rainwater and forms nitric acid. This nitric acid reaches the earth in the form of rain. That rain we call as acid rain, which is dangerous actually if it occurs heavy. But small quantity it is useful. How? Let us see here. So when this acid rain reaches the soil, the acid present in that rain water reacts with the soil carbonates to form soil nitrates in this way. So that nitric acid reached earth reacts with the soil carbonates present in the soil, suppose calcium carbonate. So these two will react and form calcium nitrate. Of course, carbon dioxide water vapor will be formed, but here nitrates of metals are formed. These soil nitrates so formed acts as excellent food for growth of plants. So these metallic nitrates can be taken by the plants for the preparation proteins in them. So in this way, atmospheric nitrogen, free nitrogen converted into useful nitrates by the nature. Okay, this is happening by the nature. We are not doing it. Atmospheric nitrogen converting into nitric oxide by the sparks. So this nitric oxide further reacts with the oxygen, forms nitrogen dioxide. This nitrogen dioxide dissolves into rainwater and forms nitric acid. This reaches the earth in the form of acid rain. This acid reacts with the soil carbonates, the metal carbonates present in the earth crust. So these metal carbonates reacts with nitric acid and form metal nitrates. These metal nitrates are very useful for the plants in the preparation of their proteins. So in this way, atmospheric nitrogen converted into useful metallic nitrates by the nature. Okay. Now let us see what are the uses of nitrogen. Just now one use we have seen, that is in the preparation of proteins by the plants, this nitrogen is used. Now let us see the remaining here. Nitrogen gas is nowadays being extensively used in food packing to keep the food fresh. As we told, this nitrogen is azote gas. It won't help the growth of any living things in its atmosphere. That's why if these food packs are flushed with this nitrogen gas, that won't allow the growth of any bacteria or any fungus inside, so that food will be fresh enough. For example, the pockets containing various snacks such as potato chips, pre-cooked and pre-washed ready-to-eat food items have nitrogen gas filled inside them. When you buy a new potato chips packet, if you press it, it will very tight enough, but fully they won't be chips, isn't it? There will be air inside. That air is nitrogen gas, because this nitrogen gas won't allow the growth of any bacteria or germs inside, as it is being life non-supporter of life, so that food will be fresh enough. If we use regular gas into the chips packets filling, what happens? That contains certain oxygen gas and water vapor. These will help the growth of bacteria and some other insects, so they will spoil the food. That is why they use this nitrogen gas to fill these food packets, which won't help the growth of any life inside. So food will be fresh enough. As being inert in nature, nowadays it is filled in electrical bulbs along with argon gas to provide more life to them. You know, electrical bulbs will be containing a filament which is made up of one of the metals called tungsten. So when we plug this electrical bulb and switch on, the electricity will be passed and will be converted here into light energy, isn't it? In that way bulb will be glown. So if that normal air, if it is filled in this, that air containing oxygen and water vapor may react with this tungsten and may be spoiled in few days itself. So to make it to give it long life, they will fill this bulb with some gases which won't react at normal conditions. Generally, they fill these electrical bulbs with argon gas. We know this argon is one of the noble gas. It won't react normally. So when you fill this bulb with argon, that won't spoil this tungsten. So bulbs will be with the long life. Nowadays what they are doing, along with the argon, they are using nitrogen gas also for filling this, because nitrogen is also not reacting at normal conditions generally. It is also being least reactive. That is why it is also used in filling electrical bulbs to give them long life. Okay. Next, one more use. Liquid nitrogen is used during skin grafting in burn victims and in vitro fertilization, test tube babies. Actually, for preservation of organs, human organs also, they use this liquid nitrogen. This liquid nitrogen gives very low temperature, where these organs will be without spoiling for long time. Liquid nitrogen is used as refrigerant for freezing food. Even for freezing food also they use this liquid nitrogen, because it gives very low temperatures to the food items. They will be freezed immediately without spoiling. They can be for long time. Okay. Even nitrogen is used in the production of nitric acid and ammonia. Okay, not only these general uses, nitrogen is also used in the preparation of some other chemicals like nitric acid and ammonia. So this ammonia is used for manufacturing of so many kinds of fertilizers and explosives. So we use so many kinds of fertilizers at our fields. So these fertilizers mostly they contain ammonia compounds. So this ammonia is prepared from nitrogen. So indirectly nitrogen is used in the manufacturing of so many kinds of fertilizers and even in the preparation of manufacturing of explosives and these all. And even some laboratory chemicals are also prepared from nitrogen. For example, nitric acid is one of the important chemical substance in the laboratory. This nitric acid is prepared from nitrogen. In this way, there are so many uses with the nitrogen. Now let us see about another gaseous substance in the atmosphere, that is carbon dioxide. Van Helmont in 1603 produced carbon dioxide by burning carbon in air. Joseph Black, a Scottish doctor in 1754, showed that carbon dioxide was a constituent of carbonates. He named it as fixed air. Okay, who discovered for the first time, who produced this carbon dioxide for the first time? Van Helmont. In 1603, he produced this carbon dioxide by burning carbon in air. Joseph Black showed that for the first time carbon dioxide was a constituent of carbonates. So by heating these carbonates, carbon dioxide can be prepared. This was found by Joseph Black. He named this gas as fixed air. Anthony Lavoisier in 1733 established the true nature of carbon dioxide as an oxide of carbon. So again, Anthony Lavoisier. So he has given so many contributions in giving the elementary nature of so many substances. Here in the carbon dioxide case also, Anthony Lavoisier established the true nature of carbon dioxide. So what he found, this substance, it is not an elementary gas, it is a compound gas. It is made up of carbon and oxygen, and he found this is an oxide of carbon. Who is that? Anthony Lavoisier. The percentage of carbon dioxide in air by volume varies from 0.03% to 0.04%. Yes, actually the percentage of carbon dioxide by volume in the atmosphere is 0.03%. But in some areas it may be varied till to 0.04%. The areas where a lot of fuel burns have more percent of carbon dioxide. So why do we say it is varying? Means in certain areas more fuels will burn. If you see in cities and towns, there will be more vehicles and industries. There will be continuously burning fuels. So by the burning of fuels, more amount of carbon dioxide will be produced. In photosynthesis process, carbon dioxide plays an important role. What is photosynthesis? Plants, they prepare their food in their own. That process of preparation of food by plants is called photosynthesis. In that process, carbon dioxide is also one of the components taken in. CO2 gas is released during respiration process. So okay, in the photosynthesis process, plants will take in carbon dioxide gas for the food preparation. But in animals, in the case of animals, they release carbon dioxide gas out during the respiration process, isn't it? They will take oxygen gas in, and their food will be converted into energy, and along with that carbon dioxide gas will be released out. What is the significance of carbon dioxide in the atmosphere? It acts as food for plants. Yes, carbon dioxide is a major source for the food production in the plants along with the water vapor. So during photosynthesis, plants absorb carbon dioxide and water vapor from the atmosphere. Of course, they take water through roots also. Mostly from the atmosphere, they absorb carbon dioxide through their leaves, and water will be taken through their roots. These are converted into carbohydrates and oxygen in the presence of chlorophyll and sunlight. In this way, they are preparing their food in the form of carbohydrates from carbon dioxide taken from atmosphere and water absorbed through roots from the soil. In this way, carbon dioxide is main source for the food production in the plants. Okay, that is one of the major use of carbon dioxide. So this reaction occurs during the photosynthesis. Carbon dioxide and water, these two will be combined in the presence of sunlight and chlorophyll. So in the presence of these two, these carbon dioxide and water will react each other and form carbohydrates like glucose. Oxygen gas will be evolved out. So this will be the food for the plants. Okay, this is a photosynthesis. So in the photosynthesis process, carbon dioxide is a major component used along with the water. Carbon dioxide dissolved in water can dissolve rocks containing calcium carbonate or magnesium carbonate. The salts so formed are calcium bicarbonate and magnesium bicarbonate. These dissolved salts give taste to the natural water. Okay, so carbon dioxide dissolved in the carbon dioxide fairly dissolves into water. So this dissolved carbon dioxide will react with the metal carbonates. Metal carbonates like calcium carbonate, that means chalk, limestone we say, and magnesium carbonate. So these metallic carbonates on reaction with carbon dioxide converts into metal bicarbonates. That means like calcium bicarbonate and magnesium bicarbonate are formed. Okay, calcium bicarbonate and magnesium bicarbonate are formed. These dissolved bicarbonates give certain taste to the natural water. Furthermore, they satisfy the needs of plants for the growth. These will be utilized with the plants for their growth, as calcium and magnesium ions are needed by the plants. So these magnesium and calcium bicarbonates will be absorbed by the plants also for their growth, because they need this sodium and magnesium. Okay, in that way also this carbon dioxide gas is being important for us. So this is the reaction occurring with the dissolved carbon dioxide in the water. So carbon dioxide in the presence of water reacts with this metal carbonates and converts into metal bicarbonates. These give the taste to the natural water, and even these will be taken by the plants for their growth. This is about calcium carbonate. If you see magnesium carbonate, this also will be shown like this. Metal carbonate on reaction with carbon dioxide in the presence of water and forming metal bicarbonate. Magnesium carbonate converted into magnesium bicarbonate. Calcium carbonate converted into calcium bicarbonate. Okay, these are important for the growth of the plants, as well as they give taste to the natural water. Right? Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos.